Okay, we're going to move on to lesson 14 here. We're still working with quadratics. First of all, let me say thank you for uh, doing the work that you guys have been doing since I've been out. Feeling a little bit better, so figured I'd give you this a shot and we'll see what we can do. So we're going to start with this very first problem here, lesson 14, 14.1. The height in inches of a frog's jump is modeled by this equation where the time t after it jumped is measured in seconds. What we want to do is we want to find the height of 0 seconds and the height at uh, zero point 0.8 seconds. Okay, so that's what these two annotations mean. H of 0 means what's the height at 0 seconds? Well, to find that, we're simply going to take our function h and we're going to substitute 0 in wherever we see the t. Minus 75 times 0 squared. When we do that, 60 times 0 is 0. And then 75 times 0 squared is also going to be 0. So the height at 0 seconds is 0 feet. Okay. Next, we want to find the height at 0.8 seconds. Okay, so we do the same thing. Substitute in 0.8 wherever we see the t. 60 times 0.8 minus 75 times 0.8 squared. And to do this, we're just going to put that right in the calculator exactly how we see it. Okay, so I'll open up the calculator here, and I want to do 60 times 0.8 minus 75 times 0.8 squared. Oh, that should be 60, not 6.0. So I'm going to arrow over here, change that to 60, hit enter, and notice the height at 0.8 seconds is also 0 feet. Okay, so here's what we have. We have a frog jumping, right? And at 0 seconds, the height is 0 feet. And at 0.8 seconds, 0.8 is over here, 0 is over here, we have it back down at 0 feet. This is the height as a function of time, and this is the time. Okay. Now the next question, how much time after it jumped did the frog reach the maximum height? And explain how we know. Well, we can figure that out. If we know that it's on the ground at 0 seconds over here, and we know that it's back down on the ground at 0.8 seconds, it makes sense that it's going to be at the maximum height, whatever is right between 0 and 0.8. So if we figure that out, we can do that by just averaging those two values, 0 plus 0.8, and then divide by 2. So we end up with 0.8 divided by 2, which is going to be 0.16. So we would expect the frog to reach the maximum height at 0.16 seconds. So the max height happens at 0.16 seconds. And if we're not positive of that, we could always go to Desmos, right? And notice I just entered that equation into Desmos. If I click on my graph, okay, it gives me the vertex. Oh, half a 0.8. That's silly. Half a 0.8 is 0.4. I did my calculations incorrect. Okay, if I click on my graph, I got all three very important points here. I see at 0 seconds, it's 0 feet high. The frog jumps. It reaches a maximum at 0.4 seconds and then comes back down and it hits the ground at 0.8 seconds. So we can come back here and we can change this. I multiplied by 2 instead of dividing. Half of 0.8 is 0.4 seconds. Okay, so that's the very first problem that we have here.